Copy C, 4-7 office hours. So check your answers quickly if you haven't already. Pause the video if you need to. I'm going to scoot the answers up. Pause the video if you need to. So the answers on the back. Okay, so let's do these. All right, so a little more integration practice. Start off with a little U-Substitution. All right, so I think we can do this without going through the technicalities of U-Substitution, because I'd say, it's going to be negative cosine 2x, but an extra 2 is going to pop out, so I need a 1/2 to counter it, plus c. Done. You could do u equals 2x, du equals 2dx. I don't want the 2. You could rewrite it as 1/2 inverse integral of sine u du. And that's going to be negative 1/2 cosine of u plus c. And then you got to change it back to x. So, I mean, in some of these really simple things where the chain rule is just going to give you an extra number in front, I think it's kind of avoidable. You don't have to do U-Substitution. This one's a little tricky. This one, if you just tried, say u equals x squared plus 9, that doesn't work. Because you have that x. So it might be like inverse trig or something. So inverse trig, there's this pattern right here, right? That gives you inverse tangent. So I think we're going for that, but there's a little problem here. That needs to be a 1. So we got to make that we need to make that become a 1 first. So we could take a 1/9 out, factor 1/9 out to make that a 1. So that works. And this is where the u squared is going to be. So you're like, well, what would you square to get x squared over 9? It'd be x over 3. So that's going to be your u. U equals x over 3. Du equals 1/3 dx. I don't want the 1/3, so I'm going to multiply both sides by 3. Now there's already a 1/9. Now there's going to be an extra 3. It's going to be du over u squared plus 1. So that's going to be 1/3 inverse tangent of u plus c. And we need to rewrite it back in terms of x for a final answer. So it's going to be x over 3. And 1/3 inverse tangent of x over 3 plus c. So, all right. Next one probably should go with u equals natural log x. Du equals 1 over x dx. Perfect. So that's going to be u to the 6 du. It's going to be u to the 7th over 7 plus c. Final answer, 1/7 natural log of x in parentheses, all of it to the 7th power plus c. Otherwise, it looks like the x is to the 7th power inside the natural log, which is not the case. Okay, cotangent. Now, cotangent, we don't have, that's not one that we've memorized rule for, so you actually want to think of it in terms of sine and cosine and do U-Substitution. So u is going to be sine x, and du is going to be cosine x dx. And so that's going to give you 1 over u du. Just going to give you natural log of the absolute value. Which you then want to change it back to terms of x. And then your limits. This one's a definite integral, or pi over 4 to 3 pi over 4. So sine of 3 pi over 4 That's going to be root 2 over 2 minus natural log of sine of pi over 4 is also going to be root 2 over 2. So we're going to get 0. Okay, all right. Next one, I think we go with u equals tangent, du equals secant squared. Perfect. So this is going to be u du. It's going to be u squared over 2. It's going to be 1/2 tangent negative pi over 4 to 0. So 1/2 sine of 0 is 0, and cosine of 0 is 1, minus sine of pi over 4 is root 2 over 2 is quadrant 4, so it's negative. Cosine is root 2 over 2, it's positive. That goes away. So that's going to become positive 1/2. Or negative 1/2? Positive. I think it should be positive 1/2. I think in my work, there's a negative here. Somehow in my worksheet, I ignored that. So it should be negative pi over 4. It's going to be positive 1. So different answer than what I got. Okay. Next one. This is in the denominator. So u equals cosine 2x. Du equals negative 2 sine 2x dx. Don't want the negative 2. So this is going to be negative 1/2 u to the negative 3 du. So it's going to be negative 1/2 u to the negative 2 over negative 2. So it's going to be positive 1 over 4 cosine squared 2x. 0 to pi over 6. Looking good. So cosine of pi over 3 is 1/2. Squared is 1/4. And cosine of 0 is 1. Squared is 1. So it gives you 1 minus 1/4 is 3/4. Okay. Next one, u equals natural log x, du equals 1 over x dx. Perfect. It's going to be du over u. It's going to be natural log of the absolute value of u. It's going to be natural log of the absolute value of natural log of x. Limits e to 6. Now, the natural log of 6 is going to be positive, so we drop the absolute values. The natural log of e is going to be 1, and natural log of 1 is 0, so the final answer is natural log of the natural log of 6. It's not natural log squared. Next one, strategy should be, let's just distribute that division and integrate the two terms separately. X plus natural log of the absolute value of x plus c. Indefinite interval, need plus c. Okay, next one I think I would distribute the x in. So this is going to be x to the 3/2 plus x sine x squared. Now I need U-substitution just for that one. U equals x squared, du equals 2x dx, don't want the 2. But don't involve this guy with that. Just integrate this guy on his own. That's x to the 5/2 divided by the new exponent. This guy I'm going to integrate with U-substitution. So sine of u du negative 1/2 cosine u. Rewrite it back in terms of x. The first term is just already good, just been dragging along. Okay, that works. Separation of variables. Solve by separating the variables. Okay, now this, it's been a little while maybe since we've done this, but it's Calc AB. So just throw a little other practice in here. Separate the variables. So you got to get the dy's and the y's together, and the x's and the dx together. That's called separating the variables. And then you integrate both sides. Right? So then you get a natural log the absolute value of y plus 5. And over here you get x squared over 2 plus 2x plus c. And usually you'd find the c value next if we could, but we can't. So now we got to solve for y. We got to get y by itself. So we're going to exponentiate both sides. Still have the absolute value. It's going to be e to the x squared over 2 plus 2x plus c is all in the exponent. And then we're going to get rid of the absolute values by doing plus or minus. And a lot of times we go ahead and do the e to the c. The rules of exponents are this is, you can think of this as e times c. And that's just going to be constant. So we're going to just put that in front. So it's going to be y equals, we call it c. You know, one of them c e to the x squared over 2 plus 2x minus 5. That's one answer. The other answer is negative c e to the x squared over 2 plus 2x minus 5. Plus or minus. Does that jog any memories? Okay, next one. I'm going to get the y stuff over here, so I'm going to divide it. It's going to be square root of y, cosine squared, square root of y, leave the x on the right. Right's going to be easy. Left, I think we do U-substitution. U equals the square root of y the 1/2, du equals 1/2, y the negative 1/2, dy, du equals, I don't want the 1/2, so it's going to be 2. It's going to be 1 over the square root of y dy. So that works well because we're going to get, we're going to get 2 du over cosine squared u. Now cosine squared, 1 over cosine squared is secant squared, right? So derivative of tangent is secant squared, right? So this is going to be 2 tangent u. And then change it back into terms of y. It's going to be square root of y. And on the right side, you're going to get x squared plus over 2 plus c. So we've done it. Now we got to get the y by itself. So we're going to divide both sides by 2, right? We're going to take inverse tangent of both sides. And then we're going to square both sides. So y equals inverse tangent of x squared over 4 plus c all squared. Oh, that's fun. Okay, next one. We got to get the y's and the x's separate. So this is going to be e to the y times e to the sine x. So rules of exponents. And then I'm going to move the e to the y to the left and move the dx to the right. So U-substitution, you're going to do u equals sine x. So du equals cosine x dx. Over here, this is going to be e to the negative y dy. And over here, we're going to get e to the u du. So this is going to be e to the negative y over negative 1. That's a chain rule. This is going to be e to the u plus c. Now, I can rewrite this as 1 over e to the y negative equals e to the sine x plus c. I think get rid of the negative for sure. And then maybe flip both sides. I mean, this is one way you could do it. And then you take natural log of both sides. So that's one answer. I think I did a little different on my solutions. I left it with the e to the negative y. And then I took a natural log of both sides. And then I got rid of the negative. So this should be the same thing. You can bring that negative inside as an exponent. Powerful. Okay, this is going to be e to the x over e to the y. So this is going to be e to the y dy equals e to the x dx. This one turns out to be a pretty nice, easy one. It's going to be e to the y, e to the x plus c. Take the natural log of both sides. Done. Okay. 17. Let's see. It says initial values, so we're going to find the c values, I guess. Okay, dy over y squared equals negative 2x dx. I usually leaving numbers and negatives on the right side. So we're going to integrate both sides. So it's y to the negative 2 is going to be y to the negative 1 divided by negative 1. Negative 2x squared over 2 plus c. I'm going to rewrite this a little nicer, but I think we should find the c value right now. So if I plug 1 in for x, I get 1/4 for y. Choose negative 4. So c equals negative 4 minus 1 is negative 5. So negative 1 over y equals x squared minus 5. So then we could just flip both sides and multiply by negative. And did I make a mistake? There's a negative here still. So this is going to be negative 3. Little mistake. All right. Flip both sides. Get rid of the negative. So it could be that. Or it could be... Keep losing that negative. Or it could be that. Okay, one more. dy, square root of y, 4 natural log of x over x dx. So then I'm going to do u equals natural log of x, du equals 1 over x dx. So this is going to be y to the negative 1/2 dy. This is going to be 4 u du. It's going to be y to the positive 1/2 divided by the new exponent. So 2 square root y, 2u natural log of x squared plus c. We're going to plug e in for x and get 1 out for y. Okay, natural log of e is 1. So it's going to be 2 minus 2c equals 0. And so 2 square root of y equals 2 natural log of x squared. And now we need to divide both sides by 2. And then square both sides. That's the final answer. Natural log of x to the 4th power. Okay, now let's do some more integrals. Start throwing in some trig, because we're going to be doing a lot more of that. And put some thetas instead of x's, just to get used to that. Okay, so antiderivative of that is going to be sine. This is a quick, easy one. One. All right. Next one. It's going to be negative 1/2 cosine 2 theta. Need the 1/2 because of the chain rule. It's negative because you're starting with cosine. So cosine of pi, cosine of 0. So that's going to be -1. Right, that's going to be a positive 1. So it's going to be 1/2 plus 1/2 equals 1. Okay. Next one is going to be theta plus sine theta. 3 pi over 4 in first. Pi over 4 in next. Subtract it. So we're going to get 2 pi over 4. I distribute that negative plus root 2 over 2 minus root 2 over 2. So we're going to get pi over 2 for our final answer. Okay, not bad yet. Okay, theta minus 1/2 cosine 2 theta. So pi over 2. Pi over 3. Cosine pi is -1, so it's going to be plus 1/2 minus pi over 3. Cosine of 2 pi over 3. Cosine of pi over 3 is 1/2. That's going to be negative in the second quadrant. That's going to be -1/2, positive 1/4, and you guys distribute this, so it's -1/4. So we can combine these together, least common denominator. So it's going to be 3 pi over 6 minus 2 pi over 6 is 1 pi over 6. And then 2 pi over 2 over 4, 2/4 minus 1/4 is 1/4. Okay. Now the next one, I think we're going to do U-substitution equals sine 1 plus sine theta. And we get cosine theta d theta works great. So it's going to be u squared du. So it's going to be u cubed over 3. So it's going to be 1/3 1 plus sine theta to the third power. It's a definite integral, so we're going to plug limits in. So sine of pi over 3 is root 3 over 2. Oh, this is ugly. Sine of pi over 6 is nice. That's 1/2. So I don't know what we want to write this final answer as. I mean, I guess we could try and take it further and further and further. We combine these together. Let's say 2 plus square root of 3 that. 2 cubed is 8. Minus 1/3. This is going to be 3/2. Cubed is going to be 27 over 8. I mean, it's getting a little better. I mean, I don't really know how far I want you to go. Cubing this is going to be ugly. I mean, squaring it, it's going to be 4 plus 4 root 3 plus 3. I'll just try it. Why not? That's going to be 7. And then you're going to multiply it by another 2 plus that. So that's going to be 14 plus 8 root 3 plus 7 root 3 plus 12 minus 27. Oh my gosh. Okay, so it's going to be 26 minus that. So it's going to be 15 root 3 minus 1 over 24. Yeah. Okay. All right. Now we're getting in for the fun. This is the kind of stuff we're going to be doing a lot more of starting in future assignments. So you got to square this. So it's going to be 1 plus 2 cosine theta plus cosine squared theta. And we can't integrate cosine squared as it is. So we use that trig identity, which you need to memorize. And we replace it with 1/2 plus 1/2 cosine double angle. Okay. If it were sine squared, it'd be 1/2 minus 1/2 cosine double angle. It's always double angle cosine. So the antiderivative is going to be 3/2. I'm doing the 1 and 1/2 together, plus 2 sine theta, plus 1/4 sine 2 theta. A little chain rule there, U-Substitution. Okay. So that looks good. So now we got to plug these limits in. That should have a theta right there. So this is going to be 3 pi over 4 plus 2 times sine of pi over 2 is 1. And sine of pi is 0. And we plug 0 in and get 0 plus 2 times sine of 0 is 0 plus 1/4 sine of 0 is 0. So a lot of these terms drop out. And we get 3 pi over 4 plus 2. So we're going to be doing a lot more of that kind of stuff with that extra thing there. Okay, next one. Similar issue. So we're going to multiply it all out. We're going to use double angle identity now. Here's a couple little things here. It's going to be 1/2 minus 1/2 cosine double angle, but there's already 2 theta there, so it's going to be 4 theta. Okay? So that's just trig. It's a bunch of algebra and trig. I haven't actually started integrating. Now I'm going to integrate. I don't need that anymore. So you have 1 and 1/2, so it's 3/2 theta minus cosine 2 theta minus 1/8 sine 4 theta. And we're going to plug limits in. So it's going to be a 3 pi over 8 minus cosine of pi over 2 is 0 minus 1/8 sine of pi is 0. Plug 0 in and get 0. Cosine of 0 is 1. Sine of 0 is 0. So a lot of these terms drop out. We get 3 pi over 8 plus 1. Distribute the negative. Okay. All right. Next one, right off the bat, we got to use one of those double angle identities. So we could bring the 1/2 in front if you want. But that's going to be 1/2 minus 1/2 cosine double angle. It's always cosine double angle. Okay. So we're going to get 1/2 theta minus 1/4 sine 2 theta pi over 2 to pi over 4. Now you might as well go ahead and just distribute this 1/2 and everything. You already got fractions. 1/4 times pi over 4 minus 1/8. Sine of pi over 2 is 1. Then we do 1/4, plug pi over 2 in. And sine of pi is 0. So we have pi over 16 minus pi over 8, which would be minus 2 pi over 16, negative pi over 16 minus 1/8. And you might be like, well, if that's the area of a polar curve, which it totally could be, like a circle, how does it come out negative? Well, we're integrating from a big limit to a small limit. So it's like we're integrating backwards, so you can get a negative answer. Okay, this one doesn't have any of the double angle stuff. So I would And probably go ahead and just distribute that. There's a little like U-substitution issue on the second part, but the first part doesn't have that. So integrate, you get theta plus 1/6 sine 3 theta. And then we plug pi over 4 in. Pi over 4. Sine of 3 pi over 4. Okay. We got to distribute that. Okay, give these guys the least common denominators to combine the pi terms together. So you have 3 pi over 12 minus 2 pi over 12. So you're going to get a positive pi over 12. Plus 1/6 times, that's going to be root 2 over 2, second quadrant positive, minus sine of pi over 2 is 1. It's a pretty ugly answer. Pi over 12 plus root 2 over 12 minus 1/6. Or you could combine them all together into a big fraction if you want. Nah. Either way. Okay, last one. You're totally on your own now. Find the area of this curve. Let's draw a sketch of it real quick, because the sketches on these are going to help you figure out how to use symmetry to make that problem easier. This is a cardioid. So we can do a quick table. So 1, 0, 1, 2, 1. So it should be a vertical looking cardioid. All right, 0, 1, pi over 2, 0, pi 1, 2 pi over 2, 2. So there you go. That's the shape. So we're trying to find the area of this whole shape. So we could do like just 1/2 and double it, if that makes sense. So I mean, we could do area equals 1/2. Okay, remember the formula is for all polar shapes, it's that. So we could just go with that and say 1/2, 0 to 2 pi, and plug in 1 minus sine squared. Could do that. Or we could use symmetry. Now, I'm going to go and just use symmetry. The only thing, it changes the limits. So if we use symmetry, we're going to find half of it. Now, you can't go 0 to pi, because 0 to pi would be 0 to this. So it would actually be 0 to pi over 2, and then negative. You'd have to go negative pi over 2 to positive pi over 2 if you want to use symmetry, which I personally don't think that's better than just doing it the original way, but I'm just going to do it just to show you. But you could just go with the original one. Now, either way you do it, you're going to have to FOIL the inside. And you're going to have to use those double angle identities for cosine. And for sine squared, it's going to be 1/2 minus 1/2 cosine double angle. It's always cosine. So we get 3/2 theta plus 2 cosine theta minus 1/4 sine 2 theta. Okay. So 3/2 times pi over 2 plus 2 times cosine pi over 2 is 0. Minus 1/4 sine of pi is 0. Cosine of negative pi over 2 is 0. sine of negative pi is 0. So a lot of these terms drop out nicely, so that's good. So we get 3 pi over 4. And then here, that's going to be plus 3 pi over 4. So that's going to be 6 pi over 8. 3 pi, no, 6 pi over 4, 3 pi over 2 for your final simplest answer.